Picking up on smooth surfaces. Again, these are characteristics of epithelial tissues. So one, they are smooth to reduce the friction. Two, they form the microvilli in the small intestine. Remember, these are folds within the folds that create a lot of surface area. So I think we showed that. They're super amounts of folds. Again, the digestive material can now seep within these folds and be absorbed into the blood that vascularizes. Well, when the blood fills, that's vascularization. Every microvilli. Cilia, we learned about those as well, just briefly discussed them when we reviewed the cell. They're projections from cells, but they move. Okay, so they they constantly sway, and the cilia, their main job is to push mucus down the throat. Again, I explained to you in class that when it gets really cold outside, your fingers can't move as fast as they can when it's warm. Same thing with the cilia. They don't move as fast when it's cold out. So when you're outside breathing in cold air, the cilia slow down. The mucus isn't thrown back down the throat like it should. So now it starts coming out your nose, and that's a runny nose. They line the upper respiratory tract. Epithelial tissue also makes your glands, sweat glands, endocrine glands, salivary glands. So as you can see in the diagram on the left down there, that the epithelial tissue on top just makes a big dip, makes a pore down there, and then the lower cells produce, by way of moving stuff out through exocytosis with the Golgi body, they release off their material, and it comes up the pore and out into wherever, on the surface of the skin somewhere, on the surface of the intestine for digestive enzymes, on the surface of the skin for sweat, on the surface of the mouth for saliva. So exocrine glands, exo for exit, they secrete it outside the body, like I just said, the salivary glands, sweat glands, digestive glands, because remember, we digest in our intestines, and our intestines are still exterior, still outside. If I ran my hand down my throat and ran it all the way through my stomach and intestines, it's still outside my body. It's still a tube. So the endocrine, endo is within, these secrete into the blood, and then the blood can transport it throughout the whole body to where they need to go, such as hormones. So all these hormones listed there go through the body. Okay, so here's a nice little summary diagram. Exocrine to the surface, endocrine into the blood. Second type of tissue we're going to talk about, done with the epithelial tissues. There's a lot of those. Second one is connective tissues. Main job of connective tissues is to connect. But there's a bunch of different types of connective tissues. Some you wouldn't think are called connective tissues, but they are. There are three major components of the extracellular material. Okay, that means outside the cell. Connective tissues secrete stuff outside their cell, and we can classify them based upon this extracellular material. So one is protein fibers, like our cartilage has a lot of protein fibers out there, which makes it tough. So collagen fibers are really tough and rope-like. Those make up our tendons. Reticular fibers are shorter, but they're also more flexible in many ways. And then there's elastic fibers, which are very elastic. And if you throw your nose from left to right, you can stretch your ear out. Got some elastic fibers there. All right, so there are three major components again. The second component is called ground substance. Ground substance is what we just call shapeless stuff in the back. You can't really see it. It's gelatinous-like, and it gives it some flexibility as well. And then the third thing rather is fluid between the cells. Blood is a connective tissue with a lot of fluid, the plasma. So types of connective tissue cells. First one, okay, basically whether you're talking about the different types, boy, this is tough. Different types of connective tissue cells, tissues You've got blood, bone, etc., but then you have two major types of cells. Okay, three types of cells. One cell produces the extracellular matrix. They call it blast cells, like Bob the Builder. Bob the Builder blasts to build. Just think blast builds, okay? BBB. Use some alliteration here. Bob the Builder blasts to put on bone, to put on stuff. You have clast cells, which chew, a CC. Clast cells chew. Osteoclasts chew bone away. And then site, and you already learned this from earlier on, anything that ends in site is a cell, which is maintains itself. So bones in general. Osteoblasts build bone. They put on, those cells put out a strong extracellular matrix called hydroxyapatite, which is a calcium mineral. So that's how we store calcium. It makes our bones tough. Osteoblasts put that out. At the same time, osteoclasts chew that down and put the calcium back in the blood when we need it for homeostasis. All other bone cells, which are just maintaining and living a natural life without taking down or taking off, basically any cell which is trapped inside the extracellular matrix is just called an osteocyte. Why are they called osteo? Because osteo refers to bone. So osteo is bone. And they just maintain like that. Yeah, there's maintaining, keeping it clean. Macrophages are a certain type of blood cell, and I taught you earlier that phage comes from the Greek word phageo, to eat. Macro is big. So in the diagram or the picture, which has been color modified, it shows a picture of a white blood cell engulfing some things. I don't know what those yellow things are, but they're eating them. Then you have mast cells, another type of white blood cell that releases chemicals for inflammation, like your histamines to make you get inflamed. That's why you take antihistamines, because your body thinks it's fighting something. Functions of connective tissues: one is to connect. They also enclose and separate tissues and organs. Oh, Lord help me, here come the dogs. So they enclose and separate tissues and organs. So connective tissue is your mesentery. Different examples: we have ligaments, connect bone to bone. Make sure you understand, ligaments connect bone to bone. When someone says something about their ligament, that means it's something strong, protein-laden connective tissue, which connects a bone to a bone, holds your bones together. Tendons take muscle to bone. BLT, bone, ligament, tendon. Bone, muscle, tendon, BMT. Still like the bacon, lettuce, tomato, but this is a MTB, muscle to bone. So tendon, if you're ever in doubt, reach down, feel your Achilles tendon. It hooks to your gastrocnemius muscle. So there you have it, muscle to bone. Another function for support and movement. Bones are a connective tissue, and they're there for support. Fat, adipose, is another type of connective tissue, and its function is storage. It stores energy. Bones store calcium. Another good property of connective tissues is insulation, physical and thermal. Again, adipose is a great insulator. You have it on your fingers, so when you pick up something, it's not pressing that muscle right up against your bone. You've got some fat padding there. Also in the winter, it's nice to put a little more fat on, keep you warmer. Transport. Yes, the blood transports everything to the cells from the outside world. Protection. So you thought just the epithelial tissue did protection, but inwardly, our body's protected by a lot of different types of cells in the blood. And the bones also protect our heart. So if you punch me in the chest, it'll hurt my bones, but thank goodness not my heart. All right, this flip notes part 2. I'm spending more time in notes this year than I did last year, so going slower. But flip notes part 2, click on this link on my website to get to it. Again, types of connective tissue in that background talk about that. How they're classified is based on their extracellular matrix, okay? Based on what they put on the outside of them. Matrix of protein fibers we call dense connective tissue, has densely packed connective protein fibers. And if you saw the picture, which I'll show you later, they are densely packed side by side, neatly parallel protein fibers. Loose or areolar connective tissue is what connects our skin to our muscles. And if we had the cats, you'd be able to feel that and see that it's really cottony like. So that they are not densely packed, they kind of go everywhere like pickup sticks. Widely separated collagen and elastic fibers that are shaped everywhere like pickup sticks. Adipose, fat. This is the easiest cell to identify because fat cells are laden, filled with adipose or lipids. So they look just like big, fat, round cells. You can see them packed out there. The nucleus, it's hard to see the nuclei here, but they're shoved way in the edge. Cartilage is made of chondrocytes. Chondro means cartilage, cyte means cell. So chondroblasts put on cartilage, chondroclasts take away cartilage, chondrocytes maintain your cartilage. There's 3 types of cartilage. There's hyaline cartilage, which is the most abundant cartilage in the body, and it surrounds the ends of your bones. So when you walk and jump, your bones aren't hitting each other. When you get older and you wear this hyaline cartilage away, then you get what's called osteoarthritis, osteobone arthritis, bone to bone. It's also one of my favorite to look at under the scope because they kind of look like little cartoon characters looking back at you. You'll see that in a little bit as well. There's fibrocartilage, which has a lot more collagen fibers, that's stronger. It's more rope-like. And then we have elastic cartilage, like in your nose and ears. If you give your nose or ears a tug, you'll find they kind of stretch a bit. So hyaline cartilage, here's a nice little diagram and then an x-ray showing the hyaline cartilage lining the ends of bones. And here are the little cartoon guys looking at you. If you see this, especially the guy in the upper right, looks like a little ghost looking at you. That is hyaline cartilage. The cells put up cartilage, the extracellular matrix out around them, and they just got these goofy looking eyes to them. They kind of occur in pairs like eyeballs, so it's super easy to see once you get used to it. Fibrocartilage, the diagram down there on the left, you can see that there they also appear pretty much in pairs, the cells do, but they've got a lot of neatly, tightly packed fibers. That's why it's called fibrocartilage. Fibers of protein that are packed in there nice and tight and pretty much parallel to each other. That stuff's between our, like on the right side shows you the spinal cord, those intervertebral discs. A lot of collagen, those ropes, and like I said, between the discs. Elastic cartilage. There's Brandon pulling his ear. On the right side is a diagram of elastic cartilage. This kind of looks like little faces too, but they're more stretched out like elastic, and they don't have as much space between the cells. Very flexible. Then bone. Bone is so easy to see. On the left side, just a cross section of a bone itself. On the right side is you're looking under the microscope at it now. And now, under the microscope, you can see those little black holes. That's where the cells actually live. That's called lacuna. That's a little cave they live in. And all the white stuff is the matrix they put on, the extracellular matrix. Those little lines, those crack-like lines radiating out from the middle, those are where the fluid goes out to feed the cells that are in those little black lacuna, because there will be a blood vessel going out central canal down the middle there, and all the fluid has to seep out and then back in to get the cells in back. And blood is very unique because it has a fluid matrix. There are some pretty blood cells, pretty easy to tell on the test too, I hope. They are biconcave shaped red cells. Remember, red blood cells are biconcave in shape. All right, I'll leave you with this, let you think about it. We'll pick up on this on Flip Notes Part 3.